This is Terry Bush with PowerMation. In this video, we're going to talk about solving the cybersecurity challenge by implementing the Perdue model with Secomea's Gate Manager Own. In the early 90s, we had people. In the late 90s, we had people with computers. And they became connected. And in the early 2000s, we started seeing Ethernet in controls. In the late 2000s, we connected the controls to corporate networks. IT departments saw this as very dangerous, as LANs, by definition, are peer-to-peer networks. These systems kept growing and growing into massive networks. And one bad actor would be unrestrained from attacking all systems. Virtual local area networks look like a good idea, but quickly became unmanageable. However, they do provide some sense of security by containing the bad actor. VLANs work in the IT or office network and can be ideal. Segmentation can be geographical or by business unit and often don't move. When installing the cubicles or the office walls, you can hard land Ethernet cables back to a centralized Ethernet switch. The centralized Ethernet switch allows a single point of connection for an IT interface for VLAN management. VLANs can limit access from one geographical business unit to another by using routing rules. Virtual LANs in the OT or manufacturing network can be less than ideal. Machines are often far away from those IT closets, requiring long cable runs. Moving those managed switches closer to the machine would lack physical security and require managing many more managed switches. OT or manufacturing engineers would have to work closely with IT VLAN management engineers, causing delays in implementation of new machines and systems. So what's the solution? The new way with an old model. That model is called the modified Perdue model, sometimes called defense in depth. Create zones for isolation, use routers and firewalls, and use demilitarized zones. You can enter a demilitarized zone, but you cannot pass through. Some examples of devices allowed in a demilitarized zones are historians, where manufacturing pushes data to the historian, and the office then grabs the data out of the historian. Application servers, where you put the programming software, you can land those inside the demilitarized zone and make remote desktop connections to program your control panel devices. And finally, jump servers, which are on-premise remote connectivity solutions. There are two ways to configure a firewall. Blacklisting is used in the office environment because of the need for so many different computer services to talk to other services. It's assumed all communications is good and tries to find and stop the bad actors. It's less restrictive of what you can do and easier to deploy, but you're assuming everyone is good. Whitelisting traffic assumes all traffic is bad. You configure which services can communicate to other services. So whitelisting is hard in the office network because of the need for all those services. Whitelisting is less complicated in the manufacturing network because you know what needs to talk to what. And typically the communication paths don't change. Using NAT routers are great for segmentation because connections are not allowed to flow down, only allowed to flow up. However, this adds complexity when attempting to connect from the manufacturing zone into the cell zone like a SCADA server might need. For SCADA server to connect to a device in the cell zone, you would need to create a network address translation rule or a hole in your router, reducing your defense in depth strategy. Let's talk about remote access and those jump servers. A local area network, by definition, is a peer-to-peer network where each device can talk to each other device. It's like a party. Routers are used to segment one network from another. The router will allow outbound communications and deny unsolicited inbound communications. It's like turning the ringer off on your telephone. You can dial out, but you can't dial in. So how do two separate devices under their own router talk to each other? Device A and B connect to the same cloud server, and the server configures routing between those devices. A NAT transversal provider is like a phone operator. A and B call the operator, and then the operator connects A to B. So you need to use secure remote access, but you're not allowed to go through the control LAN demilitarized zone. So what can you do? You can use Secomea Secure Remote Access. The gate manager is the remote server, the link managers are the users, and the site managers get installed in the control panels. And in this case, you deploy your own gate manager server. So how would all this work? First, you install the gate manager own server into the control center demilitarized zone. Site managers would be installed in the control panels. Then link managers would connect to the gate manager through a public IP translated to the private IP of the gate manager. This would allow outside vendors to remotely troubleshoot and connect to machines, all while never going through the demilitarized zone, just entering. There's extra security features like audit trails and two-factor authentication and domain separation to ensure security. And you can add log tunnel for data logging. So why is Secomea better than a traditional VPN? It's because Secomea is a relay VPN or proxy VPN. When using traditional VPNs, you give access to the whole network. You can create custom rules to prevent and limit access to devices, but that still makes you vulnerable to lateral attacks. With Secomea, you can limit not only access to the device, but also to the ports. So in conclusion, you solve the cybersecurity challenge by implementing the Perdue model with Secomea. If you have any more questions, please contact your PowerMation sales representative or feel free to send me an email at terry.bush@powermation.com.